Hello, in this lecture we will find the area of the yellow circle. In the drawing we have a semicircle and the center of the semicircle is at point O, and we have point of contact, actually 2 points of contact between the yellow circle and between the semicircle. The first point of contact is point P, and the second point of contact is point O. Let's call the center of the yellow circle M. So point M is the center of the yellow circle, and we actually know that line PQ equals to 7 times root 2. And let's connect the centers of the two circles together. That is to say, let's connect points M and O together. And actually MO is defined also as the radius of the yellow circle. Let's call it small r. Again, MO is the radius of the yellow circle because it starts from the center of the yellow circle and ends at point O, that is a point on the yellow circle. So that is exactly the definition of a radius. Any radius of the circle, of a circle, starts from the center of the circle and ends at any point on the circle. So MO is defined as the radius of the yellow circle. Okay. So actually we have a rule. I will call it rule number 1. Rule number 1 states that if two circles touch each other, internally or externally, then their point of contact lies on the straight line joining their centers. So I will read again rule number 1. Rule number 1 states that if two circles touch each other internally or externally, then their point of contact lies on the straight line joining their centers. Okay, so actually in our drawing we have point P, that is a point of contact between the yellow small circle to the semicircle. So according to rule number 1, this point of contact P lies on the straight line joining their centers, and the line segment that joins the centers, the center of the yellow circle with the center of the semicircle, that is to say the line segment that joins points M and O together is MO, and the rule number 1 states that the point of contact, that is to say point P, lies on the straight line joining their centers. That is to say, point P lies on the same straight line of the line segment MO. Okay, so actually PMO is a straight line, because according to rule number 1, the point of contact, point P, lies on the straight line that joins the centers of those two circles, and the straight line of the line segment that joins the center of the yellow circle with the semicircle is MO, and the rule number 1 states that point P lies on the same line. That is to say, PMO is a straight line because P lies on the same line of MO. That is to say, PMO is a straight line. Okay? Again, rule number 1 states that if two circles touch each other internally or externally, then their point of contact lies on the straight line joining their centers. So those two circles touch each other at point P. Therefore, point P lies on the straight line that joins the centers of those two circles. The straight line that joins those two circles is actually MO. MO is the line segments that joins those two circles together. The center M of the yellow circle and the center O of the semicircle. So P lies on the same line as MO. That is to say, PMO is straight line because P lies on the same line of MO. Therefore, PMO is a straight line, one same straight line, because P lies on the same line as MO. That is to say, PMO is a straight line. Okay, so therefore we can say that also MP is the radius of the yellow circle because it exits from the center of the yellow circle and ends at point P, that is a point on the yellow circle. Any line that starts from the center of a circle and ends at a point on the circle is defined as the radius of a circle. So MP will be the radius of the yellow circle. Therefore, actually, OP is also will be defined as the diameter of the yellow circle. We can write here that OP equals to diameter of the yellow circle. Okay, OP equals to the diameter of the yellow circle. And anyway, as you already know, the diameter of any circle equals to 2 times the radius, and the OP equals to 2 times the radius. Okay, for that reason, OP is the diameter of the yellow circle. Okay, but as you can see from the drawing, OP starts from the point O, that is the center of the semicircle, and ends at point P, that is a point of the semicircle. P is the point on the semicircle itself. That is to say, OP is also equals to the radius of the semicircle. So I will mark the radius of the semicircle as capital R, and actually OP also equals to the radius of the semicircle, because it starts from the center of the semicircle and ends at point P, that is a point on the semicircle itself. Therefore OP is the radius of the semicircle. Therefore we can say that this way we know the relationship between the small radius of the yellow circle to the big radius of the semicircle, and we can definitely say that capital R, the radius of the semicircle, is equals to 2 times small r. Okay, so we have the first equation that states that capital R, the radius of the semicircle, is equals 2 times the radius of the yellow circle, the small yellow circle. Okay, and we have another rule. Let's call it rule number 2. Rule 2 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. As I've already told you, MO is the radius of the yellow small circle, and QO is tangent to the yellow circle at point O. Therefore, the radius is perpendicular to the tangent, R perpendicular to OQ, that is tangent to the yellow circle at point O. Therefore, this angle will be equal to 90 degrees, and also this angle will be equal to 90 degrees. So I will write down rule number 2. Rule number 2 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So I will read it. I will read again rule number 2. Rule number 2 states that in any circle a radius and the tangent to that radius are perpendicular to each other. So if we have radius, let's call it r, and the tangent to that radius, let's call it t, then the radius is perpendicular to the tangent. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Again, in any circle, a radius and the tangent to the radius are perpendicular to each other. So this angle is 90 degrees and this angle also equals to 90 degrees. And we actually implemented this rule number 2, in our circle, because in the yellow circle we have radius MO and we have tangent QO to that radius. Therefore, the radius MO is perpendicular to the tangent. That is to say, is perpendicular to OQ, to the tangent of this radius. That is to say, angle POQ equals to 90 degrees, and also angle PO, let's call it L, is also equals to 90 degrees. Okay, so actually angle POQ is equal to 90 degrees. Okay, so, and we actually know also that OQ is the radius of the semicircle. Why? It's capital R, the radius of the semicircle. Why? Because OQ starts from point O, that is the center of the semicircle, and ends at point Q, that is a point on the semicircle itself. And that is exactly the definition of a radius. Any radius of any circle starts from the center of the radius and ends at any point on the circle. So OQ starts from the center of the semicircle and ends at point that is on the semicircle itself. That is to say, on point Q that is on the semicircle itself. So again, OQ starts from the center of the semicircle, that is to say from point O, and ends at the semicircle itself, at the point that is on the semicircle itself, that is to say point Q, and therefore OQ is the radius of the semicircle. Okay, so we have PO, that is the radius of the semicircle, and we have OQ, that is also the radius of the semicircle. And we know also that the side PQ of this right triangle equals to 7 times root 2. So I will draw again the triangle, the right triangle POQ. So I drew again triangle POQ. As you can see, POQ, angle POQ equals to 90 degrees. And side PO of the right triangle equals to R, and also side OQ equals to R. And the hypotenuse of the right triangle OPQ equals to 7 times root 2. Okay, so here in order to find the value of the radius, we will implement the Pythagorean theorem. Okay, so according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, according to the Pythagorean theorem, the square of the hypotenuse, that is to say PQ square, equals to the sum of the squares of the perpendiculars, that is to say PQ square is equals to R square plus R square. Okay, so I will write down the equation. So R square plus R square is equals to PQ square. Okay, R square plus R square is equal to PQ square, but we know that PQ is equals to 7 times root 2. So we can write here that R 2 times R square equals to 7 times root 2 square. Okay, R square plus R square equals to 2 times R square, and PQ square equals to 7 times root 2 square. Okay, so 7 times root 2 square equals to 49 times 2. Now we can divide the equation by 2. We will get that R square equals to 49. Okay, we divided the equation by 2. We got that R square equals to 49. And the root of 49, R equals to the root of 49. The root of 49 equals to 7. Of course, that minus 7 is not possible because we are talking about the radius of the circle, and the radius of a circle must be a positive number. So the only answer that is possible is that R equals to 7 units, but we have already found that the relationship between the small radius of the yellow circle to the big radius of the semicircle, we have already found that capital R is equals to 2 times small r, and we found that capital R is equals to 7. So capital R equals to 7. 7 equals to 2 times small r. Okay, we divide the equation by 2, and we will get that small r is equals to 3.5 units. Okay, small r equals to 3.5 units. Then we have the formula for the area of a circle. The formula of the area of a circle is pi times r squared, and we know that r equals to 3.5 units. We found that small r equals to 3.5 units. So it is very simple. We will put the value of 3.5 instead of r in the formula. So we know that r equals, small r equals to 3.5 units, so we put the value of r in the formula. The area of the formula is pi times r squared, so we substitute small r by 3.5 units, and we got that a equals to pi times 3.5 square, and 3.5 square equals to 12.25. So it is, the area equals to pi times 12.25, and pi times 12.25 equals to 38.48 units. So the area of the yellow circle equals to 38.48 units. Okay, now I will summarize the lecture. We actually wanted to find the value of the area of the yellow circle, and so we wanted to find the area of the yellow circle, and in order to find the area of the yellow circle, we have to find out the value of the radius of the yellow circle. And we have those two circles have a contact point, two contact points. The first contact point is at point P, and the second contact points of the yellow circle with the semicircle is at point O. Actually, QO is tangent to the yellow circle at point O, and it is also a contact point. Point O is also a contact point between those two circles, and PQ equals to 7 times root 2. Actually, we connected with the two centers together. The center of the semicircle is at point O, and the center of the yellow circle is at point M. And we actually have a rule that states that if two circles touch each other internally or externally, then their point of contact lies on the straight line joining their centers. So we have in the drawing two circles that touch each other at point P. Then rule number 1 states, so they touch each other internally. Then rule number 1 states that then their point of contact, that is to say point P, lies on the straight line joining their centers. Point P lies on the straight line that joins the centers of those two circles, and the centers of those two circles are M and O, and the line segment that joins those two centers together are the line segment MO. And the rule number 1 states that point P lies on the same straight line. That is to say, PMO is a straight line because point P lies on the same straight line as the line segment MO. So the meaning of the rule number 1 is that PMO is one straight line, because the rule number 1 states that the line MO, the line segment MO, lies on the same straight line as point P. That is to say, PMO lies on the same straight line, or PMO is a straight line. Okay, so for that reason, first of all, MO is the radius of the semicircle. We'll call it small r because it exits from the center of the yellow circle and ends at point O, that is a point on the yellow circle. Therefore, MO is the radius of the circle, and also MP is the radius of the circle for the same reason. It starts from the center of the yellow circle, that is to say from point M, and ends at the point that is on the yellow circle itself, that is to say P. So MP is also the radius of the circle. So, and actually we can say that OP is considered also as the diameter of the yellow circle, because the diameter of any circle is two times the radius, and the line OP equals to 2 times the radius of the yellow circle. That is to say, OP is also the diameter of the yellow circle. But the real important thing here is that OP is also the radius of the semicircle. Why? Because it starts from the center of the semicircle and ends at point P, that is a point on the semicircle itself. And that is exactly the definition of the radius of any circle. The radius of any circle starts from the center of the circle and ends at any point on the circle itself. So point O is the center of the semicircle, and point P is the point on the semicircle itself. Therefore, OP is the radius of the semicircle. And for the same reason, we can say also that OQ, this line segment, is also the center, is also the radius of the semicircle, because it starts from the center of the semicircle and ends at point Q, that is a point on the semicircle itself. Therefore, OQ is also the radius of the semicircle. So we have here the radius of the semicircle, PO, and also OQ is the radius of the semicircle. And we know that PQ equals to 7 times 2, 7 times root 2 units. But we also have rule number 2 that states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So if we have radius, let's call it R, and the tangent to that radius, we'll call it T, then the radius is perpendicular to the tangent of the radius. So that is angle is, this angle is 90 degrees, and this angle is also 90 degrees. So we can actually implement rule number 2 in our circles, because if we relate to the yellow circle, we have the radius of the yellow circle, that is to say MO is the radius of the semicircle, and we have the tangent to that radius, that is to say OQ. OQ is the tangent to that radius. Therefore, MO, that is to say the radius, is perpendicular to the tangent of that radius. Therefore, POQ is equal to 90 degrees, and also POL is equal to 90 degrees. Therefore, we actually have here a right triangle, because this angle equals to 90 degrees. So I drew this right triangle POQ again, and PQ is equal to R, OQ equals to R, and also PO equals to R, PO equals to R, OQ equals to R, and side PQ, that is the hypotenuse of the right triangle, equals to 7 times root 2 units. Okay, PQ equals to 7 times root 2 units. And here we implemented the Pythagorean theorem that states the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, 7 times root 2 square equals to R square plus R square. Okay? R square plus R square equals to PQ squared, that is 7 times root 2. So we can substitute PQ by 7 times root 2 and we square it. R square plus R square equals to 2 times R square. Here, so we have 2 times R square that equals to 7 times root 2 square. 7 times root 2 is equal to 49 times 2. We can divide the equation by 2. 2R squared divided by 2 equals to R squared, and 49 times 2 equals to 49. Then the R squared equals to 49, so the root of 49 equals to R. So we found out that R equals to 7 units. But we have already found that R equals to, capital R equals to 2 times small r. So we can write that capital R equals to small r, but we found out that capital R equals to 7, so 7 equals to 2 times R, and 7 divided by 2 equals to 3.5 units. So the radius of the small yellow circle is equal to 3.5 units. Therefore, the area of the small yellow circle equals to pi times r squared. That is the general formula for the area of any circle. And here we can substitute r by 3.5 units. That is the radius of the yellow small circle, and we found that A equals to pi times 12.25, and the area of the yellow small circle equals to 38.49 units. So the area of the small circle is equal to 38.48 units. Okay, thank you very much.